Good morning, good afternoon, or good evening, depending on where you are in the world, to today's DevOps webinar brought to you by TechStrong and Yugabyte. My name is Jared Harris, and I'll be your host for today's webinar titled Common Database Misconceptions, Distributed by SQL and NewSQL. We've got an exciting discussion ahead of you, but before we begin, I have a few housekeeping notes. Today's event is being recorded, so if you miss any of our discussion or if you'd like to share with a friend, the on-demand version will be made available shortly when the webinar concludes with a link for you to access as well. If you have any questions, we'd like for you to submit them in the Q&A tab on the right side of your screen. This is where you'll also find the chat tab where you can engage with our speaker. You can also engage with your fellow audience members, share your thoughts, or just tell us where you're tuning in from. Today we're going to have a $24 Amazon gift card at the end of our session, so be sure to stick around and we'll let you know who the winners are. Let's go ahead and kick off our webinar. I'm joined today with Michael Hagg. He is the Director of Product at Yugabyte. Michael drives the growth at Yugabyte. He's the leading open source distributed SQL database for cloud-native transactional applications. At this time, it's my pleasure to turn the floor over to you to get us started, Michael.
Awesome. Thanks, Jared. Welcome, everyone, to our packed discussion on database misconceptions, NewSQL versus distributed SQL. Now, I built this webinar for a diverse audience, whether you're technical, business-focused, basically anyone looking to understand these latest database categories and if or when you should consider incorporating them into your next database modernization initiative. I'll also look at larger trends within IT that impact the database space, as well as we'll focus on some key use cases that are becoming big drivers to some of these newer categories of databases. So essentially, you'll get a quick primer on the when, why, and what of distributed SQL. So with that, let's jump on in. And as Jared said, I'm absolutely thrilled to be here today. Again, my name is Michael Hagg. I'm head of product marketing at Yugabyte, the company behind Yugabyte DB. I've spent a lot of my time this year working with our sales team, working with large enterprises. And so I'll share some of those stories today. Prior to Yugabyte, I spent 6 years at VMware, leading their larger SaaS business. Before that, really at the storage infrastructure layer. Now that I look back at where we've come, there's a lot of parallels, a lot of innovations happening in the database space that mirror what we saw in the storage world 10 years ago. So I'll definitely share some of those insights. And as you can see on the slide, I have to apologize in advance. I'm your lone speaker today. So you're stuck with me for a bit, but I will do my best to entertain you with stories, analogies, and I've got some great random trivia sprinkled in that tie to our themes about common misconceptions. Now, I like to always start these webinars with two key things before I lose any of you to coffee breaks or pesky Slack messages. First, we'll have a bit of fun. So I want to start with some trivia. And then right after that, I'm going to give you the quick 3 takeaways for the webinar. So I want to summarize what are the 3 key points I want you to leave knowing today, and then we'll use the rest of the time to really peel back each one of those and support them and give some more details behind them. So I finished up these slides last night, so I got a bit too excited about this theme about misconceptions, but we're too late to change now, so we're going to go with it. So high level, what is a misconception? Simple definition is this is a view or opinion that is incorrect because it's based on faulty thinking or understanding, or I like to say, you read something on the internet that wasn't true. And we all have misconceptions about things. Looking beyond technology for a second, we all know about common wives' tales. Coffee will stunt your growth. Swimming after eating will give you cramps. Or my favorite, or my kid's favorite, the 5-second rule. Reality is none of these are true. But what are some other misconceptions maybe that you've heard that maybe you're not really sure about? Who's heard this one? Maybe while touring an old church or old buildings, you noticed that stained glass windows were thicker on the bottom. And you were told that, oh yeah, that happens over time. This kind of the high viscosity liquid of glass, it's super cooled liquid, will actually start to flow over time and pull some of those molecules, that structure down and cause it fatter at the bottom. Misconception, reality, the truth is absolutely false. Glass is actually neither a liquid, super cooled or otherwise, nor solid. It's actually considered a amorphous solid. So it's a state kind of in between liquid and solid. But the bottom line is it actually doesn't change over time. The reason for the thicker glass at the bottom of those windows, pretty simple, bad quality control. In olden days, it was difficult to make that perfect glass. with old techniques. So as glass cutters, craftsmen had a piece of glass that was a little bit thicker. They, of course, put that side on the bottom for stability and weight reasons. So again, essentially bad quality. Now, how about we shift this back to kind of the reality of kind of what we're talking about today. So as I've kind of said, I want to give you the Reader's Digest version of this webinar right up front. So if you leave with nothing else today, you can remember glass is an amorphous solid. And then these three realities. So first misconception we're going to talk about today. Cloud and modernization initiatives are all you need to win at digital transformation. Now, maybe I'm a little biased on this one, but the answer is definitely no. And I'll explain how we need to look at the complete end-to-end stack, infrastructure, applications, and the data layer, and really make sure all three of those elements are working well together. Second misconception, distributed SQL and NewSQL are the same. So this is the premise of our title for this session. So we'll definitely spend time here. And this is, again, false. They are related, but as we look at where the database market has evolved, distributed SQL is truly a new architecture built from the ground up with visibility to all these recent trends we'll look at, whereas NewSQL attempted to deliver some scale, but really is built on just the traditional SQL architecture that we've known for forever. And then finally, kind of the third misconception we'll dig into today is that your existing stack is good enough for modern use cases. Now, there's some nuances to this one, but the reality is that the answer may be maybe. But as we're seeing and hearing from customers more and more of these modern use cases, and we'll talk about 5 of them today, there's a reality that, again, that full end-to-end stack, having a data layer that provides the agility, the availability, the performance that you're getting from these other pieces is really important. So we need to make sure we mirror these two things together. And if you notice these 3 topics, essentially kind of happen to work out that we'll really be hitting on the when, the what, and why of database modernization. So again, my goal is to really walk you through that thinking and get you ready to think about your next database modernization project or where these solutions can help fit into what you've already done. All right, so those are the big takeaways. That's what we're going to get to today and uncover. So with that, let's jump in, and I'll start to peel back this first one. So how should we think about prioritizing database modernization? When should you really look at these new types of databases? Well, good news is you made the first step. You're here today. So congrats. We're excited to have you here. But for this kind of first misconception, we really want to explore this idea, again, of kind of when is the right time. We all know, like all of us, you have a lot on your plate. There's a lot of competing priorities. There's a limited set of time, a limited set of resources, budget. So the misconception I hear often is, I have other priorities now. It's just not the right time to dig into the database. It's working fine. What kind of advantages would I get? And depending on where you are in that modernization journey, some of that may be true, but I really want to dig into that statement and explore some key things just to keep in mind and kind of open up your eyes to the reality of the world we live in and some of the pieces going on around it. But before that, we're going to keep going through these fun trivia misconceptions. So here's something that isn't actually what many of us believe. So I told you there'd be kind of random trivia here. So I'm sure you're all familiar with Napoleon Bonaparte, the French military leader, part of the French Revolution, and he is historically portrayed as extremely short. Anytime we kind of make fun of him, you see him as short. In fact, that notion is so pervasive that there's this phrase, the Napoleon complex, that exists that refers to someone with an aggressive attitude or that comes across as a form of overcompensation for being physically short, smaller. But was Napoleon really short? Or again, is this misconception that's just kind of bred over time? And the reality is Napoleon wasn't actually that short. At the time of his death, he measured 5 feet, 6.5 inches, or 169 centimeters. And if you look at the average height of an 18-year-old man in just a couple of years ago, it was about 5 feet, 7 inches. So Napoleon by no means was tall, but he was just a bit under average. And kind of this confusion, this pervasive notion that Napoleon was this extremely short man was kind of due in part one to the crazy French and British measurement systems at the time. They actually had different numbers, and he was actually 5'2" in French measurements, so it sounded shorter. But more of the credence to that notion is given to a British cartoonist by the names of James Gilray, who portray Napoleon increasingly as this short cartoon picture in his cartoons. So at the kind of near the end of Napoleon's life, he actually said that Gilray did more than all the armies of Europe to bring him down. So he actually had a little bit of a sense of humor there as well. But as we shift then back to this notion of IT stack, what's important here, like with Napoleon, is to really look at the full picture, kind of get the facts and look at that full stack kind of from top to bottom. So everyone defines this IT stack a little bit differently, but here's how I think about it. And I'll go through this quickly as again, you'll be familiar with this, but really there's kind of 4 key elements that we want to think about. At the very top, we start with the application. We're in a software world. Applications drive everything from services to customer experience. So that's the heart of it. So we have our application layer. At the very bottom, we have our infrastructure layer, storage, servers, virtualization, cloud, live down here. And then sitting in between the two, we have our data layer. This is the layer that serves up the data to the application layer and then resides on that infrastructure underneath. And then I'm going to focus on those 3 points in the middle, but I didn't want to ignore just around all of this, of course, we have network and security. So we have these additional tools, monitoring, management that help kind of collect and build everything together. But let's think about these stacks, these elements in the middle, and what has changed over time. So starting at the bottom, what's happened in the infrastructure layer in the past 2 decades? The answer is we've seen massive changes. This started with virtualization, the movement to commodity hardware, the abstraction layer drove up resource utilization, and then we just rushed head on into the cloud era. Everyone has different numbers for kind of the cloud, the size of the cloud industry, but if you look at the past 10 years, some estimates show it going from 25 billion in 2010 to over 150 billion in 2020, purely in cloud infrastructure spend. That's a 6x increase. It's probably conservative to a lot. As I'm sure all of you know, all you have to do is look at the growth in AWS, look at the kind of the resurgence of Microsoft thanks to Azure, Google, Alibaba, other players that are just revolutionizing this. And then, of course, just look at the projects that you're dealing with. There's no doubt that we live in a vastly different infrastructure world today than we did 20 years ago, and all for the better. And then let's look at the top of the stack. This is a little bit more of a recent change, but we have seen major changes in this stack as well in application modernization with containers, microservices, Kubernetes, new app frameworks, all fundamentally changing how we think and build applications. It's changed how developers are productive and what they focus on. We're a little bit early on in this journey, but still we're seeing tremendous growth. If you look at similar numbers to this space, according to Research and Markets, the global market for app modernization services is estimated to be a little bit shy of 10 billion in 2020, but growing at 20% over the next few years, surpassing 30 billion and beyond in just a matter of 5 years. So again, tremendous set of focus efforts in the application space, and it's resulted in a fundamental change in how we think about applications. Now you can all read kind of between the lines of where I'm going with this. So my next question, the middle layer, what about the data layer? So as we said, this forms the foundation for any application. It's essential to any businesses that are becoming more and more data-centric, which is essentially everybody. Yet despite that critical role and sitting right in between these 2 layers that we've literally spent hundreds of billions of dollars upgrading and changing over the past 10 years, who are the major database players? These are the names that have literally been there for decades. If you look at the rankings on DB Engines, they look at all the 300 plus databases out there, rank the popularity and usage. Oracle still sits at number 1. This is a company that delivered their first commercial relational database model before I was born. And don't let these fancy camera filters fool you. I'm not that young. I'm getting old now. Second most popular database, MySQL. This was built and delivered back in 1995, the same year we were introduced to Toy Story. Not number 2, 3, 4, or Buzz Lightyear, but the original Toy Story. So these go back some times. Now, I say this not with, again, these databases are amazing. They have driven tons of innovation, and they're amazing products. But given what we just talked about the amount of money and innovation that have gone into the cloud infrastructure and the app infrastructure, this middle layer was architected before those contents were even scribbled on someone's napkin. And looking at the number again, I mean, the RDBMs, the relational database market, everyone has different numbers here. It's easily a $50, $60 billion market And still the bulk of that, 80%, is being spent on traditional databases. So databases that were built, designed for a world that had no concept of containers, had no concept of kind of widespread multi-cloud world, and before we met Woody and Buzz. And IDC expects this market just to keep growing. It's not slowing down. Data isn't critical. So we're seeing this go. So to really put this in perspective, I was trying to come up with some good analogy. I was scouring Google for some good images of like a Ferrari with wooden wheels, or maybe a laptop that still had a floppy drive soldered on the side of it. I couldn't quite get those, but I wanted to get some visual to illustrate how I view this market. And a couple came up that seemed somewhat relevant. So I know this is ridiculous and would never happen, but imagine if Apple ignored investing or figuring out an updated speaker or microphone for their phone. So when we had this fancy phone that we know today, but in order to talk on it, we had to carry around an old receiver, shove that in our pocket. Now, I am old enough to remember using these handheld sets. So for you younger folks out there, old physical phones, big receiver with a microphone, and speaker on it that you actually had to hold up your mouth and hold it there. Or what if, in order to play music from the phones, we still had to rely on an antiquated turntable? So again, crazy examples, but put this in perspective of what you may be doing in your IT stack. And again, sorry, I missed the slide here, but here's the quick visuals here. I got ahead of myself. You can kind of see again what I'm talking about. Imagine again taking that phone, fitting that in your pocket with the old receiver. So going back to and thinking about our IT stack, imagine again what hell happens if we kind of keep down this path of again innovating at the top and bottom, but are ignoring that middle layer and still expecting this legacy technology to still keep up with the latest demands of our developers, of our customers, of our business. The good news is we are seeing tremendous growth in distributed database systems. If you plot some of the top distributed SQL offerings, again, through DB engines, you can see that they're some of the fastest growing today. So the momentum is building. We're starting to see this investment, people realizing that, hey, I've got cloud more or less figured out. I've got modernization at least moving in the right direction. Now let's make sure we map that out and have an end-to-end solution on top. And then just to close this section on a lighter note, don't be this guy. Think about how you can find those strategic projects that require an end-to-end modern approach. In our third section, again, I'll talk about some very specific use cases that we are seeing drive customer demand for distributed SQL. But what we find is that customers that keep trying to fix and make do with legacy systems, they're putting more onus on the developers to just solve it in the application, slowing down innovations and making it harder to manage over time. So fix it before it's broken and really think about a clean end-to-end solution to align with those other strategic initiatives you have as a company. So the time when is now or probably pretty soon. All right, so we talked again a little bit about that when, set the context of distributed SQL and the data layer in kind of this larger picture of the IT stack. Now let's get to the heart of the webinar. Again, I position this as NewSQL versus distributed SQL. So what is the difference? So this leads us to our second misconception to explore. Misconception: NewSQL and distributed SQL are the same thing. So as part of the Yugabyte product team, I work with our sales team, our customers a lot. When we talk about Yugabyte as a leader in the distributed SQL space, and when we kind of had that conversation and brought up distributed SQL, it wasn't uncommon to have customers ask us kind of what that meant, and then they thought, is this the same as NewSQL? Because it's a term that we'll talk about has been around for a little bit longer. It got to a point earlier this year where my sales team kind of kept asking us and kind of were questioning, why are we going down this distributed SQL path? Like, isn't it the same? Like, why are we trying to reinvent a term? And as I stated earlier, I strongly believe that NewSQL and distributed SQL refer to very different things. They have very different characteristics, and there are very different stages in the evolution of a database. So with that, let's kind of peel back the history of these terms and start to kind of dig a little bit deeper. But before that, another trivia which helps set the stage. So another great misconception that I actually had for a while, and I'm sure you've heard this one, is the Great Wall of China is the only man-made structure visible from space. I mean, it's a massive structure. It stretches over 13,000 miles, 21,000 kilometers. So it's got to be true, correct? Well, sadly, no. I mean, as amazing as it is, it's not visible. According to NASA, astronauts traveling in low Earth orbit or on board the International Space Station, they can see quite a bit using the naked eye, but the Great Wall essentially just blends into the rocky, hilly terrain of China. There are a couple of man-made structures that are visible, though, without modification. You can see highways, you can see dams, of course, you can see kind of city lights, bridges. And in fact, there is one ancient wonder that is visible. There's actually some great kind of pyramid, some images of without any magnification that let you see the pyramids of Giza. Again, nice clean background of the desert. They stand out a little bit. Okay, but kind of why does this matter? Trivia is great, but bringing this back into a subtle segue to our topic, the takeaway here is that perspective is important. The Earth today and 200 years ago from space looked pretty much the same. I mean, green, blue, brown blobs, that's pretty much what astronauts see. You can see the most of, and then as it clears, you see a little bit underneath. But of course, as you examine Earth from a closer, as you kind of dug into it, clearly our landscape, our world has changed drastically in 200 years, thanks to man, our innovations. Database categories are a little bit like that. At the furthest level, kind of high level, they all serve a similar function. Their goal is to help organize structured data so that applications can access it and retrieve it. But as we get closer, as we dig into the details, we start to see some major differences there. And that's exactly the case as we think about NewSQL versus distributed SQL. They both kind of came about with a similar problem statement. So in that regards, they do kind of share the same DNA for where they came from. The goal was that after years of SQL and NoSQL, people realized they wanted to find a way to combine the scalability and resiliency of NoSQL with the consistency, the performance, and transactional support of the relational data model. A great goal and one, again, that's shared, but how they do that is a little bit different. So let's start just quickly with kind of the NewSQL History 101. So as far as I know, we have to give credit to Matt Aslett at 451 Research, who first used the term NewSQL 11 years ago to describe a new breed of relational database players. Matt wrote about these new companies that were trying to do something a bit new, but he didn't realize the term was going to kind of become this broader industry's term over time. Now, the initial companies he coined the term NewSQL to describe haven't really had a material impact on the database. If you look back, most of them have been acquired or after a few years closed the doors. And what these NewSQL companies focused on doing was taking existing RDBMS architectures like a PostgreSQL database and layering on top of it a way to do automatic sharding to help, for example, a Postgres database span across clusters and region. So again, and they came with this mindset of taking all the goodness of SQL and building a little bit of capabilities on top of it to deliver that scale. The goal made a lot of sense, but it was a 1.0 version and a bit ahead of its time. Massive distribution of data 10 years ago wasn't a top priority in the early days of cloud adoption. Companies were still fighting over the infrastructure modernization and starting to hear about containers and gear up for that. They just weren't ready for this massive distribution of data. So essentially, like many great 1.0 ideas, they didn't quite become mainstream. But along came distributed SQL to help deliver kind of what we can call a 2.0 version of that idea. As Matt described in a follow-up paper more recently, we learned a lot of lessons from NewSQL that helped fuel the second generation of companies to tackle this idea of embracing scale, distribution, cloud-native features, all within a relational database. So the distributed SQL term was born to describe, again, these 2.0 companies. Over the past decade, we've seen the demand for global distributed databases increase along with, again, that increase in public cloud adoption, as well as cloud native and other trends have just pushed it forward. And so there's a new set of companies and existing cloud providers that have looked to tackle this problem of combining SQL and NoSQL by not just building on top of it, but really rethinking the architecture from the ground up. We can also give credit to Google Spanner. They published a paper that really talked about kind of this distributed transactional layer at the bottom, the storage layer, that has become the genesis for a lot of the newer solutions we see today. And as these companies have kind of rebuilt themselves from the ground up, again, we've shied away from the NewSQL term and really embraced distributed SQL, which makes sense as it's a more descriptive term that really articulates the value. Let's peel that back a little bit more. And I was wanting to come up with a kind of an easy way to think about the differences between NewSQL and distributed SQL. And I thought we could learn a lot from the automotive industry and kind of the changes we've seen over the past 10 to 15 years. After decades and decades of building and innovating on standard combustion engines, so again, similar architecture cars have been running for a long time. More recently, past 10, 15 years, we've seen the emergence of electric vehicles, so providing an alternative way to power transportation. Now, this flip, I mean, by no means is it complete, and it didn't happen overnight, but there was, just like with databases, there's been this evolutionary process. And I really want to clue into two specific examples. I want to talk about the Toyota Prius, specifically the hybrid model, which has a hybrid drivetrain, both combustion engine and electrical vehicle motor, kind of an EV motor. And then talk about the Tesla Model S, this kind of the first kind of mass-produced electric car from them, which is 100% electric. Now, both cars were kind of designed to tackle a similar problem of around efficiency in reducing pollution. But again, they went about it a very different way. So thinking about the Prius, it took the original architecture of a combustion car, added in an electric motor to assist and provide some power from batteries versus relying only on gasoline. As a result, we saw a tremendous increase in fuel efficiency, but it didn't really tackle the full problem. As you still had all the complexities of all the combustion pieces, and now you had this added electrical layer and these other pieces that had to work together. So it worked, but if you ever tried to do any work on a Prius, it was impossible. They were just so complex, and again, they were still held back by some of that original design. And as you can see on this slide, this is very similar to NewSQL. Again, a great idea, and it provided some value. So NewSQL was the same way. The initial NewSQL companies provided basically an automated sharding layer on top of multiple instances of monolithic SQL databases like a Postgres. Now, those traditional SQL databases did not scale horizontally on their own. So with the NewSQL capabilities, it added some level of automation to share data across different instances and clusters. So you can now share data, again, between areas, again, these clusters spread apart. So you now have this ability to use multiple nodes in context of a SQL database, but to the fundamental architecture, there were no significant changes, meaning the replication architecture didn't change. So you still had those limitations where if you wanted to do kind of complex synchronization between nodes or geolocations, if you wanted to use joins between these instances, none of that was supported. So you got some of the scale, but you were still kind of stuck in those limitations of what Postgres has. Because again, it was really just these independent instances that had some level of communication between them. So kind of in the end, we saw this advance towards scale, but it was only going to take you so far in this move to truly a kind of a distributed architecture nature. And so this brings us kind of the second parallel, kind of the flip side. Let's talk about the Tesla Model S. Now, Elon Musk kind of pushed this vision. He was just set on really delivering 100% electric car, building it from the ground up. The Tesla engineers really rethought about every part of the design. They didn't just take existing pieces, kind of parts of the car and say, okay, we're just going to use what combustion cars have been doing for a while. They looked at the importance of everything. For example, the importance of low center of gravity. So they designed the batteries in this kind of flat sled pack that sits all across the bottom of the car, distributes weight very evenly. A lot of the weight is in those batteries, so it keeps the center of gravity very low on the car. So really thought through how do they optimize this car for an electric world. But with this said, I also have to kind of acknowledge that Tesla realized that in order to be wildly adopted and to become mainstream, they couldn't just go crazy with the architecture. They couldn't rethink the concept of a car from the ground up, in the sense that they couldn't do something like this. They couldn't go out there and choose a design that really pushed the boundaries, that had people scratching their head on is that really a car? Is it safe? How do I get in it? I mean, all these basic questions. So they maintain that nod to what we expect from a car. Again, looking at the picture here, it looks similar to any other four-door sedan out there. So it has that level of familiarity. It has that comfort where if someone gets inside of it, they essentially know what they're doing. And then they start to uncover some of the differences with regenerative braking, the design, the weight distribution, all those things that do make it different. Okay, so going to databases. So kind of like combustion cars, original SQL databases, Oracle, Postgres, MySQL, they're monolithic. They have that kind of standard architecture. And those databases just aren't built to distribute data and queries across all these instances. It's not part of their DNA. So what distributed SQL vendors came to do is they really redesigned from the ground up a new architecture for today's cloud-native world. They were designed so that the entire database cluster, irrespective of the number of nodes and how far apart they sat geographically, looks to an application as a single logical SQL database. It's a logical relational database deployed on a cluster of servers that automatically replicates and distributes data across all of the servers. And it does that basically without any knowledge of the kind of application on top. It kind of hides all that as this black box that just takes care of all that stuff for you. And you think about the kind of key qualities that pretty much all distributed SQL databases share. They have a SQL API for accessing and manipulating data. They have automatic distribution of data across nodes in the cluster. They have automatic replication in a strongly consistent manner. They have support for distributed query execution. Again, you can kind of complete a query or one, again, that you've already written, and the system will know how to go distribute that and pull the data across all these different shards spread across the world. And then, of course, it supports ACID transactions. It maintains, again, that strong consistency in all those ACID properties that people expect from a relational database that's designed to address transactional applications. So with all those descriptions in mind, let's kind of just plot out those features, just to kind of really bring it home on how these databases compare. We'll start with the traditional SQL and NoSQL. Plotting them on a SQL graph here, y-axis showing scalability, x-axis representing data consistency. You can see the trade-offs made. SQL was first, again, really focused on consistency. NoSQL came along a little bit later in kind of the late 2000s, kind of 2009. NewSQL came on board as cloud was growing and really focused on scale. And they gave up some of that consistency. So again, these trade-offs exist. So you got one kind of high up on the Y, but to the left, the other low, but to the right. And then as we think about where NewSQL fits in here, again, as we described, it's taking just that SQL architecture and delivering some level of scale on top of it. So basically moving SQL up the y-axis a little bit. Now, there's a third dimension that's important to capture. As time went on, these kind of two vectors mattered, but there were some other characteristics that fall into this newer bucket of cloud native. Now, my 3D graph skills in PowerPoint are limited, so I've added a shaded region to represent this kind of third dimension, this idea of cloud native versus monolithic. As we think about, again, cloud native applications, just kind of moving to multi-cloud, there are some other key features that are critical. We hear again and again about the importance of open source and open standards for flexibility and transparency. Multi-cloud, of course, as we move into that world. Being platform agnostic, running anywhere. Having dynamic orchestration, so all this built-in intelligence and being able to self-heal and take care of itself. All of these qualities are important. NoSQL, from kind of a scale, from multi-cloud, kind of crosses that line, so it's kind of has a kind of a foot on each side of that line. NewSQL maybe a little bit, but this is really where, again, as we think, kind of as we were thinking about where to plot distributed SQL, you can see it lands again further to the right as we add this element of cloud native along with consistency on that x-axis. So distributed SQL is designed to take us a little bit further into this cloud native world by, again, being born in the cloud, supporting all these key capabilities. It has the scale of NoSQL, that consistency of SQL, and I would say it takes that consistency a step further, again, by having that being consistent across environments and worlds. So we kind of see the evolution here and can see, again, going back to this initial misconception that, again, there are fundamental differences as we think about NewSQL and distributed SQL. And to really drive this point home, as debating on the best way to show this, so we're getting the kitchen sink here. I won't go into this table in detail, but we can map out those features and kind of go into the features in more detail. We can look at kind of key features in each of the rows, and then the 4 columns representing SQL, NoSQL, NewSQL, and then distributed SQL. We can still see how they rank. Now, for the distributed SQL, I look specifically at Yugabyte DB, again, because some of those answers will vary based on the distributed SQL solution you look at, which is true for some of the others, but we wanted to make sure we kind of capture at least one viewpoint on distributed SQL. And you can see here that, for example, NewSQL pretty much matches the capabilities of SQL, with the only difference being that scalability row. We see NewSQL introduced horizontal, where SQL remains kind of that vertical scaling where you just have to buy new servers to move up. And then if we kind of help this pop a little bit more, if we take a slice of this where I highlight kind of what I deem as the better feature, kind of the better result for each feature, I've kind of in green kind of circled, squared those features that provide kind of the optimal experience for each of those features. Now I recognize schema, language, depending on your application, your needs, there's no right or wrong answer. If you just need SQL, then who cares about the supporting something else? But kind of the point here is we are seeing, again, distributed SQL solutions like UGBDB have a multi-model approach. They support both SQL, kind of Postgres compatible API and Cassandra compatible API. So you get some flexibility there. And then as you go down that list, again, they take the best of NoSQL and SQL, horizontal scalability, strong consistency, automatic replication, high availability, and then pile on, again, that third dimension, some of those cloud native features and things that we look at. In the market, I mean, you and your peers out there, again, are definitely recognizing these advantages that Distributed SQL delivers. Again, based on 451 research, we are seeing more and more enterprises use or plan to use globally distributed databases. Up to about 58% of those in the most recent Voice of the Enterprise said they are using it or have plans to. And this number just keeps going up. We expect as some of these misconceptions, as the awareness of what Distributed SQL brings, that number is just going to keep going up. And again, our next section is really going to hit on kind of why that is. And then just to round up kind of the close on this section, if nothing else, this is kind of a diagram I kind of created as I came into Yugabyte that really kind of captured the essence of what Distributed SQL is doing. It's, if you think about this Venn diagram, you've got relational database features, consistency, familiar interface, security. You've got, that's kind of the SQL world. You've got non-relational, resiliency, scalability, distribution. And then you've got, again, this third dimension of this idea of future-proofing, open source, multi-cloud, hybrid. Distributed SQL solutions like UGBDB really combine the best of all of these. So you live in the middle, they eliminate those trade-offs that you're having to make with your traditional solutions and deliver a lot more. And again, and I think it's critically important, we kind of talked about, I kind of hit on this notion of Tesla, not kind of creating just this crazy, unfamiliar looking car when they had the opportunity to. They chose things that made sense for an EV car, but also that made sense to what our perception of a car is, what are the skills we as drivers have, what do we look for as a buyer. The distributed SQL databases that have done that as well. They may have revolutionized kind of under the scenes how we distribute data, but they're still providing familiar APIs. If you have applications that are written for Postgres, those are kind of, we're wire compatible. You can execute those right away in UGBDB because we support that API layer. Cassandra the same way. We have these familiar interfaces that you know of. So from an application development standpoint, it looks like, again, a single logical database. You're not fundamentally changing how you write code. What you are changing is that you no longer have to keep track of shards. You no longer have to deal with replication in the application layer. So giving you the ability to simplify how you handle applications and get all these benefits of a distributed kind of layer underneath. All right, a lot there. And I want to get into this third section. Again, we've talked about kind of the when, and then hopefully clarified through charts, tables, and analogies, a little bit of the what of how you can think about NewSQL versus Distributed SQL if that was still an open question. And then I want to close on this last section of the why. I mean, why should you start using Distributed SQL solutions? And there are a number of key use cases out there, many of which I'm sure many of you are facing today that are fundamentally easier to solve and can make your life a lot easier when you start to shift to a modern approach. So kind of the final misconception on that table we start off with was that, again, maybe you're thinking, hey, my existing IT stack and database works fine. I don't need to invest in changing today. So let's look to prove if that's the reality, or again, if there are fundamental reasons why you actually should be looking at changing today. All right, and last random trivia, kind of general misconceptions to talk about today. And this one I thought was, we'll see, this one's very appropriate. So kind of I love this idea and the fact that most of us, I mean, since again, my kids are younger, if I ask them, they know our five senses. They're like, everybody asks, hey, what, growing up, we're taught, hey, you have five senses of the human body. You can, and let's see if you can, in your mind, if you can rattle them off: smell, touch, taste, sight, and sound. It's just kind of a given that those are our five senses. But is that true? I mean, do we really only have five senses? The reality is, nope, it's actually way more complex than that. I mean, if you think about it, it makes a ton of sense. And I'm not sure why it would boil down to just kind of five as a kid. But people say that we actually have up to close to 20 different senses. These includes things like balance, spatial awareness, pain, and my favorite or least favorite, hunger and thirst. So again, all these things you can think about that your kind of your body, these senses your body has to tell you when to do things, when you're falling, when to go eat, when to go to the bathroom, all those things that go a little bit beyond just those basic five senses. Now, why did I pick this to kind of lead into this section on databases? So just like everything in the world, including our senses, things have gotten more complicated. It's rarely good enough anymore just to cover the basics. In our jobs, we have to go deeper and handle an increasing number of asks and use cases to help our business grow. The applications you're making are no exception. Basic availability or consistency, just not good enough anymore. As a developer, you need to build an application that can run anywhere, span clouds. And then once you do that, you've got to make sure it can survive cloud issues like region failures, network differences, security protocols, new compliance requirements, and the list goes on. And then, of course, you've got to do all that without sacrificing any of the customer experiences and the performance. So like our senses, we need to understand and be ready for different and sometimes more subtle requirements in these use cases. Which kind of leads me to my list of 5 things we'll talk through here. And I started off number 1 with just the core need to support transactional application growth. Whether you're at a startup or enterprise, we all hope that our application and services will become widely popular, but we never quite know which ones are going to take off or when. What's going to be the catalyst that suddenly drives this application surge in demand? Do we architect with a 5-year plan in mind? Does something go viral that suddenly 1 year from now we need to address? So we kind of have to face the reality that if we're successful, inevitably we need to be able to plan for this application scale. And if you think about dealing with that growth in legacy solutions, I mean, it's not easy. Until recently, SQL databases and their monolithic architecture have essentially relied on a single write node backed by specialized kind of high-cost hardware. As your application scales, you need to, as it expands, you need to upgrade to bigger and better servers, and then eventually you'll hit the limits on that server. You've got to upgrade again. If you're dealing with the cloud, there are limits. The cloud only has so many instances, types of offerings out there. So it just becomes this constant move, which eats into kind of complexity. It always adds risk when you're doing those. So you're just limited with what you can do. And then as you're doing this, I mean, the other part is it's putting more and more demand on your developers. So again, your developers have to kind of deal with limits. If the limits are hit, what you do. So again, kind of pains all around. And actually talking to the kind of developer relations team that I work closely with, this is a slide, so a little bit busy here, but that they refer to pretty often, where it's not really a question of kind of if you're going to hit this scale or if you're going to need to think about a new architecture, but a question of when. Again, we're all optimistic. We go in with the idea of seeing our business, our services grow. So if you kind of start with just kind of simple manual sharding, then you're going to start, as you need to scale, you're going to start having to handle manual sharding, do it in the application. You just get into this world of complexity. If you're dealing with replicas, with single writes, you're again hitting these bottlenecks as your application grows. There's no easy way other than migration to move it forward, which leads us again to a key premise, a key value of distributed SQL databases, of having this flexible, scalable environment that, just like you do on the infrastructure layer now with cloud, where you just build out your clusters as you need more compute memory resources, we can do the same at the database layer now. So as we think about distributed SQL databases, this notion of horizontal scalability is that fundamental feature. And thanks to it, operations team can effortlessly scale even under heavy load without disruption or downtime, just by adding nodes to the cluster. And then that built-in intelligence of distributed SQL will automatically rebalance. It'll kind of maintain this equal weight and make sure, again, eliminate the hotspots and do all of that behind the scenes for you. And the other equally important part here is not only do you get the scalability, but it doesn't impact performance. As you kind of, again, classic systems, as you add more and more to it, it can slow things down. But we're able to maintain those low latencies, that high performance as that system scales. Again, thanks to decisions made in that fundamental architecture that build this in natively to it. Now, if you're trying to take distributed SQL and compete in performance against just a single node, or you just have a small application that needs to run just on a single server, that specialized single node database is probably still going to outperform. But again, as you get to scale, as you get into a world where you need to shift from kind of this left side to the right side with your application, distributed SQL makes that world that much easier. A great customer example here is looking at kind of a real world example. Again, wanted to pull in some of these stories just to make this a little bit more real for you, is Temenos. So they're a great example of where app growth was critical to their business, and it drove their investment in basically re-architecting their banking cloud solution. If you're not familiar with Temenos, they're one of the world's largest banking software ISVs. They support over 3,000 clients and actually support 41 of the world's top 50 banks. So again, mission critical. They do a ton and support pretty much every kind of bank that you're using today. And what's happening in the financial services world is we're seeing this rapid increase in the number of transactions. In fact, again, Temenos kind of shared that they're seeing the number of customer transactions has increased 10x over the last 10 years. Again, you just think about digital payments. You think about the fact that we're paying for, we're going to buy a candy bar with our credit card. We're running kind of putting $2 and just putting down our phone to pay for it. So the number of transactions is increasing, which to them has put massive pressure on their traditional database systems. And at some point, those largest servers just weren't big enough anymore. They needed to expand out. They needed to scale so they could support, again, hundreds of thousands of reads and write operations per second for mission critical applications. And this is where, again, Distributed SQL came in, provided that ability to scale out, let their application grow seamlessly over time. Okay, use number 2, top of mind for any IT leader out there, and that's availability. How do we ensure that we can deliver an always on business that can survive outages with zero impact to customers, and ideally zero impact to the operations team, so we're not again increasing our operational costs. So kind of what are the options to build an always on business? Again, kind of almost all databases, including distributed SQL databases like Yugabyte DB, they use replication to ensure that the database remains highly available under failures. Basic idea is to keep copies of the data on independent failure domains so that the loss of one does not lead to data loss or data unavailability. However, the key differences lie in the constraints of the replication solution for each database. If we think about the most common replication mechanism in PostgreSQL, it's that of asynchronous replication. You have 2 completely independent database instances that are deployed in a primary standby configuration in such a way that the standby instances periodically receive committed data from the primary. Now, that standby instance does not participate in the original writes, so it's not impacting latency of the write reads. But if that primary system fails, you lose availability, and you lose the ability to service recently committed data until you do a manual failover to bring those systems back up and shift that standby over to act as primary. So pager cell phones go off, people get up in the middle of the night. Operational teams don't like this. So let's go back to our comparison, this kind of idea of NewSQL kind of being the same as distributed SQL. Even though NewSQL databases automated the sharding, they didn't do anything to kind of, again, re-architect that high availability piece to replicate kind of replication. It remains the same. So as these databases started running in shared infrastructure of the public cloud, where failures can be more frequent, this meant that those rare manual failovers suddenly became a lot more common. And users realized that that's just not sustainable. They do not want to be in this game of having to deal with not just the occasional corner case failure, but having to do that as a regular part of the job. So with distributed SQL databases, the goal is to really build an always-on business as part of just that native architecture. Critical services, because it's distributed, remain online during node, zone, region, or data cellular failures. And you also have those fast failovers. Also, with built-in intelligence and automation, those databases heal themselves. So the operational team no longer is responsible for making sure it rebuilds it and keeps it going. So again, automation, simplicity are key there. And if a great example here is one of the world's largest global retail companies operates a huge e-commerce site featuring thousands of sellers, millions of products, and they power that today with Yugabyte DB. Underpinning this offering is a wide portfolio of microservices that handle large volumes of data. They manage how the products are listed, displayed, grouped, filtered, searched, kind of all those cool things that go into the customer experience. A recent event perfectly demonstrated kind of the value of distributed SQL's always in architecture. In the US, this retailer operates across 3 Azure regions with both classic legacy databases supporting some of these apps and then other apps running on Yugabyte DB. Now, a major ice storm hit Texas in 2021. Now, crazy rare for the region, does not happen very much, but we live in unpredictable weather patterns nowadays. So what happened was US South Texas region was offline for 4 days. What this retailer discovered, though, is all their services powered by Yugabyte DB had 0 loss of data, and traffic was automatically rebalanced to the other regions in just a matter of 3 seconds. So a little pause to the end user, and everything just kept on running because you have this seamless distribution, this no single point of failure, where if one side goes down, the system knows how to keep going, and it knows how to rebuild, rebalance, and just keep operating. So when we talk to the company there, they're like, nope, we're good, leave us alone. We have our hands full, basically spending days recreating, manually reconciling all of their traditional databases and getting those back up and running. So needless to say, we've seen further interest in distributed SQL as part of that. Okay, third use case is really driven by app portability. So this is the freedom to move applications across clouds and consolidate across multiple environments. Now, applications can be easy to move, but if you move the application without the underlying data, you're not going to have much help. So it's really that data that can become the anchor, slowing down those goals around app portability. And the reality is, again, lots of numbers out there, but about 80% of organizations out there use multiple clouds today. So this flexibility is critical. When you have, again, these legacy approaches, they'll handcuff you to a single location. Having to do that movement is complex, expensive, professional services type of engagement that adds a lot of time. The other thing is, again, if you've made a decision, a lot of us realize that either applications that we thought would be good in the cloud just aren't running there, or maybe we discover the costs, the availability, the compliance requirements just don't match what we wanted, and we need to be able to move those back. So again, this flexibility to shift resources around is growing important, and again, just very hard with that traditional environment. Another key element kind of to the story is around app portability is this notion of multi-cloud. And I highlight this specifically because, especially for financial services, there's this growing discussion around cloud concentration risk. It refers to the fact that control over critical digital infrastructure is increasingly in the hands of a small number of major providers. So while public cloud providers provide flexibility, stability, the distributed IT environment, there are growing concerns around its operational resiliency and having, again, all of your eggs in one basket. I know this is top of mind for a lot of regulators in EMEA and financial institutes over there. So they're requiring more and more companies have a multi-cloud approach. And as you're moving more and more into a hybrid cloud world with on-prem and public cloud, you're moving into both public cloud and public cloud, having a unified platform data platform, this data layer that can span across all those, again, just makes those tasks that much easier. And this is really where, again, as you think about distributed, the data layer, it comes into play here. As a single logical database to the application, behind the scenes, it has built in, again, different replication technologies, the ability to distribute data across multiple clouds. We recently did a number of demos with Equinix, running on Equinix Metal and with AWS, basically showcasing this distributed data layer that spanned across both. As reads and writes happened on one environment, they basically in real time showed up on the other. And then as you wanted to move database kind of applications between the two, you had this consistent data layer underneath, and it made that application movement very easy. And then just looking at, again, I don't want to try to show too much of kind of the Yugabyte DB interfaces here, but just kind of showing just how ingrained it is into that architecture is as you think about those infrastructure choices through the UI in Yugabyte DB, you can see here to easily choose between AWS, Google Cloud, Azure, VMware Tanzu, Red Hat OpenShift, and more, as well as, of course, just the on-prem environments for you. So multi-cloud, being able to have that app portability is key. The fourth one is around next-gen Edge. So Edge is an extremely hot area. 1.0 version of Edge was really about pulling in data from Edge devices, so kind of back to a central data center. But as we think about the next generation of Edge, it's becoming increasingly about not just getting data from the edge, but it's actually keeping the data close to the edge and making decisions, making real-time choices at that place. So whether it's the device edge or far edge, which we also refer to as robo, you really have challenges distributing that with a legacy device. But going back to this notion of a distributed database, it inherently has that scale, that cloud agnostic approach, platform agnostic to run on a variety of different platforms to let you move that data layer out more and more. So we really get this notion of a unified data fabric that can tie together our edges and power all of these emerging applications. GM is a great story where, again, they've got a massive set of connected vehicles, previously referred to as OnStar, 20 million plus out there. They've now replaced their kind of legacy NoSQL database with distributed database in order to, again, collect information from those cars and deliver more and more data-centric services to their end customers. So it's essentially opening up their business and freeing them from a lot of the complexities, a lot of the development challenges they had with legacy systems. All right, last use case here, and I'm flying through these quick, so thanks for hanging in there. And this is one that's touching all of us, microservices and Kubernetes. So again, going back to that stack I talked about, thinking about all those investments at the application layer, how do we make sure we're building a modern stack underneath to support them? And this particularly becomes true when we think about stateful applications. So we're seeing this shift more and more away from just stateless applications that can just go away as needed to stateful applications that actually require storage to not be part of the container, to not be part of the host, but to just survive outside of that construct. So as you have this kind of ephemeral nature of Kubernetes pods that require the need to reschedule them, to constantly move up and down, you want a database underneath that again, has that agility, is designed to support that kind of dynamic nature and behavior that we see in Kubernetes. And so distributed SQL database, again, we combine all those features we've talked about so far, and it comes in to be able to, again, have maybe an architected with cloud native architectures in mind, with Kubernetes in mind and containers, so that you can provide that low latency, resiliency from failures, and horizontal scaling. And again, pretty much every customer I talk to, this is a part of their push to distributed SQL. So they have this mindset of cloud native. How do we get to a database that aligns to that? A huge financial institution went down that journey. Again, they had the full stack, microservices, they have Kafka kind of events and CDC pipelines as part of it. So that larger ecosystem, again, not only were they able to scale and support that with Yugabyte DB, but they saw, again, that massive performance savings as well by shifting away from legacy mainframes, their previous DB2 environment. All right, so we covered a ton in that last section. And again, these, again, are 5 use cases. So as you're thinking through your projects, as you see these come up, these are 5 things to kind of have on your radar and have that light bulb moment go off when you should be thinking about distributed SQL. And then just to recap our misconceptions and the takeaways from today. 1, we're all at a different stage of our transformation, but remember, think about end-to-end stack, cloud, app, and data layer. If anybody asks you distributed SQL, NewSQL, they're the same. Now, hopefully you can articulate the differences, go back to your Tesla versus hybrid analogy, and talk about that core architecture that differentiates them. And then finally, those use cases. Think about these 5 use cases and identify those that make the sense for your business and when you should move to distributed SQL. So with that, I covered a ton there. I went through quickly, but hopefully this gave you a good insight on the when, the what, and the why of distributed SQL. Reach out to us with more questions on Slack. Give Yugabyte DB a try for free on cloud.yugabyte.com, and have a great day.
All right, outstanding. Thank you so much, Michael, for taking the time to join and share your expertise with us. Just a quick reminder that today's session was recorded. Following this panel, you'll receive an email with a link to access the recording on demand. You can also find the recording on devops.com/webinars. Look in the on-demand section, and it will be waiting for you there. Now, on to the 4 gift card winners while we've still got a minute. We've got Antoine O, Alicia C, Bento E, and Maria G. Congratulations to the 4 of you. Keep an eye out on your inbox to claim your gift card. If you do not receive it in your inbox, please be sure to check your spam folder. There have been times that it shows up there. Michael, again, thank you so much for taking the time to be with us. I'd also like to thank Yugabytes for sponsoring today's webinar, and I'd also like to thank each of you, our audience, for staying with us for the entirety of the presentation. Please take a moment and fill out the webinar post survey once this session closes, and hope to see you in our upcoming webinars. I am Jared Harris, and I'll be signing off. Have a great day.